Mr. Oosthuizen here with covalent bonding. It's the overlapping of two or more half-filled orbitals in nonmetals, and this show is about bonding in gases specifically. We are going to look at the formation of the diatomic molecule for hydrogen consisting out of two hydrogen atoms. Remember that these electrons must have opposite spin, therefore the one is showing upwards and the other one is downwards, so that they can actually share one orbital. When they approach each other, the half-filled orbitals will overlap. Now the two electrons share the same space, therefore the formation of the H2 molecule. In Lewis notation, with dots and crosses, it is going to look like that. And then in Cooper, only the bonding electrons are shown and no other electrons. So only the bond, the dot and the cross, become a line. That is a single bond and therefore also a weak bond. The next one is the formation of the O2 molecule. In oxygen, one atom is filled with electrons up to 2p4. And note again that we have opposite spin in these electrons. As they overlap, only the half-filled orbitals will overlap. In the middle, you see the two overlapped orbitals, therefore the formation of O2. The Lewis structure will then show two bonds between the two oxygen atoms, and the rest of the electrons are shown as lone pairs around the oxygen. If you go to the Cooper structure, the two electron bonds in the middle become the two lines. No lone pairs are shown for the Cooper structure. It is a double bond. It is therefore stronger than the hydrogen bond with only the single bond. Then in water, again we have on the left the oxygen atom with electrons filled up to 2p4, and then we have two hydrogen atoms on the right ready to overlap with the half-filled orbitals from oxygen. Note again that the electrons spin in opposite direction for the hydrogen atoms. They overlap with the two half-filled orbitals, therefore the water molecule formed. The Lewis structure then, two hydrogen atoms with their single electrons overlapping with the oxygen atom with two half-filled orbitals, forming the water molecule like that. The Cooper structure, specifically, remember it will be an angular molecule because of the lone pairs on oxygen. Then the formation of the CO2 molecule, carbon dioxide molecule. For this, we are going to look at two oxygen atoms on the left and on the top, two oxygen atoms, and then on the right, the one carbon atom. Now carbon, remember, has only got the two half-filled orbitals, but carbon never bonds in this state. This is the ground state for carbon. As it receives energy mostly from the sun, one of the lower level electrons will be excited to fill one of the higher level orbitals. Therefore, you will now have four half-filled orbitals for the carbon atom. We call this the excited state for carbon. Therefore, the two half-filled orbitals from both oxygen atoms can now overlap with these half-filled orbitals. First one will bond there, and the other one will bond there. Also remember that the four orbitals for carbon actually have the same energy state once the electrons are all in their half-filled positions. Therefore, in the Lewis structure, carbon in the excited state will four unpaired electrons bond with oxygen to form the CO2 molecule, and in Cooper structure it looks like that with two double bonds, therefore it is a linear molecule. Then to summarize, covalent bonding is the overlapping of two or more half-filled orbitals in the nonmetals. That concludes the lesson on covalent bonding.